Hello everyone. Today we'll discuss about depression detection using federal learning. So in this, if you are uploading any audio, so by using this federal learning, it detect healthy or depressed. So out of that machine learning, so we are going with that new technology as the federal learning. So in this, like we can use the multiple device so to train the models, but without exploring their local data sets. So for an example, if we have five different types of client, so those five different types of clients also have different types of local data set. So we will be trained by using this federal learning separately. So one client will not share their dataset to one more client. So after training locally sub dataset, so they will share their models weight to one place. So which is nothing global model. To get that global model, so it will collect from all the five clients local weights. So then that will converted at the main model. So again, that main model will reshare to all those five clients. So now the first client can check the data sets of fifth client without sharing their fifth client's data sets. So this is the main concept of our project. So without sharing their local data set, they will be trained and they will be able to test by using this global model of the other clients also. So here you can see that for that we have used MLP as the multi-layer precipitations and which is nothing like about the binary classification. So we are going to predict healthy or depressed like that. And then homomorphic encryption we are doing. So by using the CKS seeds. So which that locally model weights are encrypted. So before the transmitter. And then this is the block diagram. Here you can see that we have, for an example, here we have two clients. So each clients, they will take their local data set. Then each data set like pre-processing and noise injection, mode, PCA, encryption weights. And this is for the MLP encrypted weights. So for that encrypted weight, we are using MLP. So it will evaluate and it will aggregate to the server. Okay, so now the clients once model it goes to the server, but without sharing the local data set. That model can access by the client to local data. So again, it goes for the server. So like this, without sharing their data set, they will send each model's weight to the server, and this server creates one global model which can use for the both the clients. So this is the folder of our project. Like here you can see that we need to create as the server and the client. These two things is the main important. So before that using the server, we need to create the CKKS content generator, which is nothing. This is the secret key. So by using this key only, like we are going to transfer the models weight for the server to client and client to server as well as. So here you can see that in the client code. So in that client code, first we need to set average number of clients. So in our project, we have set only two. So like number of clients is two. So this is the MLP before as I told, like MLP we are using for the binary classifications. And first we are encrypting our weights. So from that data set, we need to encrypt our weights. Then we need to decrypt it. The main concept like federal learning flower. So they will tell us the FL client. So by using this only, we are going to get that local model of the clients. Okay. So once if you run this, you will print that client ID with the local model. So that will be stored as the extensions of PTH. Okay, so then these functions to get the parameter and set the parameter. Finally, we are fitting all those models as to create the global average model, right? So then we need to write one function as the fit, so which helps to get and collect the all the local data set which will be converted into global models. So once if you run here the client ID and LT or depressed, it will display there. So this is for the client side. So in server side, so what are the client side? They are sending the data that will be received as the server side. So to receive, we need this CKAS. So first we need to load this encrypted context. So by using this only, what are the values or data or something they are sending from the server clients. So that will be get through the server. So here you can see that this is the global matrix tracking and aggregation fit we are doing here. So here you can see that number of round we have given as the 100. So 100 round, the data set will be trained and models weights will be get from the clients and it save as the server. So in this server only we are creating the global model which will work for the all the clients. This is the testing code. So finally, you will get one model. So depression audio model dot h file. This is the model you will get there. So by using this model, we are going to predict by uploading the audio whether it is healthy or depressed like this. So here like we are loading the model and this is the model path we have set here and feature extractions we are doing here. So after feature extraction by using tick inter like file dialog. So if you run this automatically go for the folder and it asks to select the audio and it detect what types of audio it is. So let me run and show you. So if I run this, so by using this tick inter automatically redirect to the folder. So here you can see that. So in this data set, we have two. So depressed or healthy. So for an example, I'm clicking from the depressed as one audio. So here by using this model and it analyzes and it will display as the output. So in this healthy, I'm uploading one audio and it should goes for the model and the model makes the predictions. So here it is displaying as the LT. So like this, we are going to predict it. So the main concepts of our project. So without sharing our data set, we can share our model weights and we will get one global model. So by using this model, so if we have 5 different types of data set, we can check all those data set. And thank you all. I hope you like this project and we'll meet with one more good project in the next section. Thank you.